Have you ever looked at something you use every single day and thought, what would it take to make this perfect? Well, today we're taking this ordinary water bottle and giving it a serious high-tech upgrade. But this transformation, it's part brilliant engineering and part hidden danger. Let's get into it.
So what does that even mean to truly upgrade something? Is it just about making it look cooler? Or does it have to perform better? Or is it something way more complicated? That's really the question we're digging into today.
And here it is, our subject for this experiment. Just a simple, well-loved stainless steel water bottle. I'm sure you've got one just like it somewhere. It gets the job done for sure, but it's definitely seen better days. And you can really see its story just by looking at it, right? You've got the chipped paint, all the scuffs and scratches, those classic wear rings on the bottom. It's lived a full life. But all this also shows the limits of its original design. And that's what makes it the perfect candidate for what we have in mind.
So this bottle's story, all this wear and tear, it leads us right to the solution. A special coating that promises to fix all these problems, and then some.
And that solution is black chrome. Now this stuff has a real dual personality. On one side, it is an absolute powerhouse of function, and on the other, it's a jaw-dropping aesthetic upgrade. Let's break down what makes it so special.
Okay, functionally, black chrome is a total beast. It actually helps the bottle keep its temperature better, it protects the steel underneath from ever rusting, and it makes the whole thing way more durable and scratch-resistant. So the big takeaway here? This isn't just a new coat of paint. It's a genuine performance upgrade that's going to make this bottle last so much longer.
And then you've got the looks. We're talking about going from that chipped, dull, matte finish to this deep, rich, premium metallic surface. And it's a look that doesn't just look amazing on day one. It's designed to resist fading and all those annoying fingerprints over time.
So, how in the world do you apply a coating like this? This is where things get really fascinating, where we dive into the high-tech chemistry that makes this whole makeover possible.
Yeah, you definitely can't just spray this stuff on. The prep work is incredibly meticulous. First, you have to strip every last bit of old paint off and deep clean the surface. Then there's this acid activation step called pickling. After that, you lay down a super important nickel underlayer, and only then do you carefully mask off the parts you don't want coated, like the threads for the cap.
Let's just focus on that nickel layer for a second because it's so important. The best way to think of it is like the ultimate primer. It is absolutely essential for making the black chrome actually stick to the steel, and it's the real secret to getting that perfectly even deep black color. Without it, the whole thing just fails.
Okay, so after all of that prep work, how thick do you think that final layer of black chrome actually is? Get this, it's only 0.2 to 1.0 micrometers thick. To put that in perspective, a single human hair is about 70 micrometers thick. This coating is literally dozens of times thinner. That just shows you the incredible precision we're dealing with here.
The result is, well, it's a flawless, high-performance finish. It seems absolutely perfect. But this is where our story takes a very sharp turn. Because this kind of beauty, it has a really dark side.
See, behind that sleek, durable surface, there is a serious hidden cost. And it's a cost you can't measure in dollars and cents. We're talking about significant risks to human health and to the environment.
And this is the source of that risk, hexavalent chromium, also known as chrome-6. It's the key chemical ingredient that makes this whole process possible. It's also highly toxic, heavily regulated, and yep, a known human carcinogen. And the health risks from being exposed to this stuff are no joke. We're talking about a documented risk of lung cancer, serious skin ulcerations, and damage to your eyes and nose. It's incredibly dangerous for anyone working with it if they don't take extreme precautions.
Because of all these dangers, its use is, as you'd expect, strictly controlled all over the world. Major organizations like REACH in Europe and OSHA and the EPA here in the US, they have very stringent rules in place to limit how workers are exposed and to prevent it from getting into the environment.
So let's bring this all back to our water bottle. The risks here are pretty unique. For one, if that masking on the rim we talked about fails, even a little, you could have this hazardous material right where your mouth goes. Plus, think about the extreme temperature changes a bottle goes through, from boiling water to ice water in an instant. That could potentially cause the coating to flake off over time.
So, after this whole journey through performance, precision, and, well, peril, what's the big takeaway? Let's kind of step back and reflect on what we've actually learned here.
You know, this quote from the source material really gets to the heart of it. The goal was pretty simple. Create a finish that's beautiful and functional. But as we've just seen, the process to get there is anything but simple.
And this really sums up the central conflict, the core trade-off. On one side, you have the gain, an object that performs better, lasts way longer, and looks absolutely incredible. But on the other side, you have the cost, a process that involves serious health risks and requires intense, strict regulation just to manage safely.
Which leaves us with one final big question. And it's a question that doesn't just apply to our water bottle, but to so many of the amazing technologies and materials that shape our world today. When is getting that perfect finish worth the hidden risk?